Hey, it's Horner, and this is the 2005 AP Physics 1 problem. First thing that they want us to do here is go through and draw a free body diagram. So I'm actually going to draw two. One of them is the free body diagram that you're going to write right on here. So straight down is mg. Then for this one, there is a force to the right. This is the force of tension for the horizontal, and then up this way, this is just force of tension. So I'm going to draw another dot. Remember, whenever you do these, you only want to put forces on this one, and then on the one that you draw over here, you can draw whatever you want to help you solve the problem. So this is the force of tension horizontal, and then this one should have components. And they put the angle, oops, there we go. They put the angle right here. So we're going to put the angle there, and we know this is force of tension times the cosine of the angle, and this one is force of tension times the sine of the angle. Cool. Now they want us to find out what is the tension in the horizontal string. So first thing we're going to do is let's find the forces in the y direction. So that's equal to 0. And if I look in the y direction and we make up positive, we're going to say that this is ft cosine of the angle is minus, so here's mg going down, and that's equal to 0. And now I have ft is equal to mg over cosine of the angle. Now we're going to do the same thing, and to the right, we're going to call that positive. So this is the sum of the forces in the x direction is equal to 0, and I know that I'm going to do the force of tension in the horizontal minus the force of tension times the sine of the angle is equal to 0, because notice this is to the left, this is to the right. So now I have the force of tension horizontal is equal to the force of tension, that's this one, times the sine of the angle. But we said the force of tension is mg over the cosine of the angle. So we're actually going to plug this in so that we can actually solve. So we're going to plug it in right there. And we're going to get the force of tension horizontal is equal to mg over cosine of the angle times sine of the angle over 1. And sine over cosine gives you tangent. So this is mg, tangent of the angle. So let's go ahead and plug all of our numbers in. If we go back up, we see that our mass is 1.8, and the length of the string is 2.3. So we don't need the length here, we just need the 1.8. So we're going to move up here. This is 1.8 times 10 times the tangent of, and then I think our angle here was 30 degrees, and that's correct. So mg tangent of 30. All right, so if you do that math, you should get, and the class we're in right now, second period, says it is 10.4, what's my unit? Newtons. Very good. Okay, so there's our final answer. Alrighty, let's move on. Oh, before we do that, let's put points on this. If you were getting points on an exam, you would get 1 point for this, 1 point for this, and you get 1 point for drawing the mg. You would get 1 point for showing the sum of the forces are equal to 0 in both directions. You would get a point for filling that in. You'd get a point for combining it, a point for plugging everything in, and a point for your answer with unit. So notice that this is 3, 4, 5, 6, 7, 8, 9, 10 points altogether for just that first part. And that, I know, I realize is all forces, but remember, that'll be on your AP Physics 1 exam, so you got to know that. Now they say the horizontal string is cut close to the bob and the pendulum swings down. Okay? Calculate the speed of the bob at its lowest position. So let's go ahead and do that. We know that it's getting cut right here, so it swings here through. We said earlier that we know that this is the length. If we draw our triangle and have an angle here, which we do, this side is L cosine of the angle. And so our change in height is equal to L, which is the entire length from here to the middle, minus L cosine of the angle. All right, cool. Here we go. Think about this with energy. So if we think about it with energy, we know at point 1 it has potential, and point 2 it has kinetic. So we know we're going from potential energy due to gravity, and that's equal to kinetic at the bottom, which means you need to have mg delta y is equal to 1/2 mv squared. Now it's really easy to just memorize the equation for this one, but if you just write that down, you won't get any credit. You've got to show that energy is conserved. So you need to have these two things to get this 1 point. Now we can cross off the m's. So bye-bye m's. We're left with v is equal to the square root of 2 times g times delta y. That's equal to 2 times 10 times L. So remember our L here was 2.3. So L is 2.3. So I got to put in 2.3 minus 2.3 times the cosine of 30. And when I'm done, what speed do I get? Yeah, about 2.48 meters per second. And is that a tangential speed? Is it tangent to the curve of the circle? Yes. Yep, because it's circular motion. Good. So that is how you do this question.